So here we have our last topic, piecewise functions. By its name, they are just the functions made up by multiple pieces of functions. On average, there will be one problem all about piecewise functions. Usually on the midterm, they will ask you the continuity of it, including whether a given piecewise function is continuous on a boundary, which is just a point where the two pieces connect. Okay, so the boundary points is the keywords. And how you can achieve to have the given piecewise function continuous. Finally, they can also ask you whether the piecewise function is differentiable on the boundary point. So let's look at this question. We want to find the point C such that the function is continuous. Okay, so C is actually the point that I refer to as the boundary point. If you kind of sketch the two straight line out, you got this as 3x plus 2 and this as 4 minus x. Okay, so you pretty much want to find the purple point over here as your boundary point, so that the purple point can you will kind of have this as your piecewise function. This is what we're looking for. Okay, this point has the property that this will equal to this, okay, because they intersect at this point. So you equate these two and you solve for C. It's just that easy. And then you solve for C equals to 1/2. So let's work on this problem. Now we have three pieces. We're gonna find f prime. So f prime, well, you have three pieces, then you're just gonna do the derivative piecewise. For the first piece, you will use product rule. Okay, so now you have two terms, and we do the derivative for the first part first, leaving the second part original, and plus leaving the first part original, and then doing the derivative for the second part. The second part involves chain rule. Okay, so you're deriving sine something over here, and so that's cosine something. Okay, but you're gonna do the chain for that, so that's the derivative of the inside, and that's it. Of course, you can simplify it a little bit. And the second one, well, it's 0, so the derivative is just 0, but then it's only 1 point over here, so f prime is really just 0 for x equals to 0. Okay, the third one, the derivative is just 2x for x is negative. With the same problem, now we're asked whether the derivative of the function is continuous at 0. Okay, so as we saw from the last part, we already got this. Okay, and with the answer simplified already. So now let's see what we should do. Okay, so if you want a function, even now it's a derivative of a function, okay, but it's still a function. If you want a function to be continuous, then you want to have this. Okay, so remember the definition. So this is our definition, and that actually should have a prime over here. Okay, so this is your function, and your function has the limit has to be equals to the function itself evaluated at 0. Okay, so by following that, so let's take a limit. Okay, because we already know the right hand side has to be 0. That's what we're told over here. Okay, and the solution claimed that f prime is not continuous at 0 because the limit as x approaching to 0 from the right hand side does not exist. Well, let's see what happened. Okay, so if you want to approach the limit from the right hand side, you're gonna be looking at this piece. Okay, so that's what they're talking about. Okay, so let's see how it does not exist. Okay, so if you want this function to approach 0, then over here you will have some problem over here. Okay, I think both this and this would bring a problem. Okay, because they're in fact oscillating functions. Okay, so the solution bring this one, and they tell you that this can be made as large as you want by choosing some positive number. Okay, that is really close to 0. Okay, because here you will have 1 over a really small number, so that's gonna be a really large number. Okay, and this is kind of oscillating near x equals 0.